In this next example, we're going to reverse the process of the prior examples. In other words, we're going to take the sum or difference of logs and write them as a single log. This is an important skill in solving certain log equations. We start off with log base a of 7 plus 4 times log base a of 3. Whenever you have a coefficient on a log, that coefficient can be written as an exponent on the argument to the log. So I'm going to have log base a of 7 plus log base a of 3 to the 4th power. Then what I have is log base a of 7 plus log base a of 81. Now I'm taking the sum of two logs with the same base on the log. Therefore, the sum of these logs can be written as the log of the product. That gives me log base a of 7 times 81. So all we need to do now is figure out what 7 times 81 is. That result gives me log base a of 567. Let's do the same idea with this one, except here we notice that we're subtracting instead of adding, which means I'm going to be writing as a log of a quotient. For starters, we notice that I have a 2/3 here. That 2/3 can be taken and made an exponent. So I get the natural log of 8 to the 2/3 power. 3 to the 4th power we know is 81. 81 minus 8 is going to give me 73. So I have minus the natural log of 73. Now we need to deal with that rational exponent. Raising a number to the 2/3 power is equivalent to taking the cube root of that number and then squaring the result. And so I have the natural log of the cube root of 8 and then squared. The cube root of 8 is 2. 2 squared is 4. So I have the natural log of 4 minus the natural log of 73. Now, since both of these expressions have the same log, base e, and I'm subtracting, I take this log and write it as a single log as follows. The natural log of the first term goes in the numerator and the second term goes in the denominator. So I have the natural log of 4 over 73. Let's do one more example. In this last example, we have a lot of stuff here. What we're going to do is work our way from left to right in this problem. So for starters, I have log base a of x plus log base a of 9. That can be written as log base a of 9 times x, then plus log base a of x squared plus 1 minus log base a of 5. In these next two terms, I have the sum of two logs with the same base, and therefore I can write that as the log of the product. So that's going to give me log base a of 9x times x squared plus 1. And I'm going to put all that in brackets. And that's minus log base a of 5. Finally, because I have the same base on the logs and I'm subtracting, I can write this as a single log with a quotient. That's going to give me log base a. In the numerator, I'm going to get 9x times x squared plus 1, and then divided by 5. I now have my logarithmic expression written as a single log.